Hi, everyone. Thank you for jumping on this webinar early. It's about 2 minutes after the hour. I'd like to give just one more minute because we have a lot of people logging in at the same time. I want to be sure that everyone's able to get logged in before we start this important webinar. We do have our speakers online, and you should be able to see the slide deck also now. Just a reminder to those of you who are online early, thank you for that. And for questions, the Q&A period, you have a question button over on the right-hand side. Use that to type in your questions, and at the end, we'll have the Q&A period, and we'll do our very best to get those questions answered straight away. We will provide the recording and the deck, a copy of the slides. Thank you, Michael. We will provide those at the end after the webinar. We'll also be providing, for all of you who registered, you'll remember you will be emailed a copy of the full white paper. So we'll send those along with any additional questions that might happen to come in that we don't get a chance to go into. So thank you for being on today. And looks like we're about 4 minutes after the hour. So if you don't mind, I think we'll go ahead and get started. As the others join, we'll just catch them up. I'm sure they'll be fine to catch up as we get into all of this. So again, let me welcome you to the webinar. I am Bobby Harris. I'm the new Executive Director of the Utility Broadband Alliance. And first, a quick word from the legal side about UBBA, our confidentiality and antitrust. Although we are certainly a very collaborative and sharing organization, we also want to make sure we protect what we need to protect. And for those of you who are new and don't know, UBBA actually began forming in early 2019 and has developed and matured as really a hub of information sharing and collaboration and planning to advance, planning for what needs to happen to advance private broadband. And over the first 2 years, the Alliance really evolved even beyond our initial goals. And on February 5th of this year, we formalized as an independent 501c6 and have been gathering new members all along. Of course, as a utility-driven organization, UBBA's mission really is to champion the advancement and development of dedicated broadband networks and really foster collaboration among the ecosystem of our members. Our working groups, as part of that collaboration, we have working groups focused on business drivers and challenges, use cases, technical architecture, cybersecurity, and key policy and advocacy sections of utility broadband networks. And today you're going to hear from some members of our working groups on some recent work. The Cybersecurity and Technology Working Group has created a white paper, Cybersecurity of COTS, commercially available technology, and embedded devices over utility LTE networks. And you see on the screen the list of key contributors who helped write this paper. It was many months in the process, a lot of back and forth on what should be considered, but just a lot of hard work went into this. Now, of course, I want to also thank the larger Cyber and Technology Working Group as a whole for doing the editing and the approval process, and all of the members, including the new board of directors, for approving the paper. The top three names there, though, are the guys who you're going to hear from today. First, Adam Spratt from Southern Company. Adam has worked as a security team lead for Southern Company's wireless telecommunications company called Southern Link for the last 6 years, and he's the co-author of their cybersecurity program. He's very active in cybersecurity working groups from CTIA, UTC, EEI, and of course UVBA. He's a member of the InfraGuard partnership between the Federal Bureau of Investigation and members of the private sector that are focused on U.S. critical infrastructure. And I'd be remiss if I didn't say he is a lifelong St. Louis Cardinals fan, hence the background he's got today. And he is also a terrific husband to Taylor and father of two beautiful children. You'll hear from Adam a little bit later. Next up, Gino Scribano from Motorola Solutions. Gino is currently serving as the private broadband LTE system architect with a focus on critical infrastructure market. And over the course of his better than 3-decade career, Gino has been responsible for standardization, design, development, implementation of cellular infrastructure, and products for commercial and public safety use. So thanks, Gino, for being with us today. Also then, Jairo Hernandez Guzman from Council Rock. Jairo has been a member of the product development group within Council Rock since 2016, and he's a key contributor to the implementation of security features such as full disk encryption, the secure bootloader, and application security for their private LTE product line. Prior to joining Council Rock, Jairo was conducting research in topics related to the digital signal processing at Rochester Institute of Technology. So I'm very grateful to have all three of these guys here today. And you've heard me talk enough. I'm going to go on mute. I'm going to turn off my webcam because that's enough. And I'm going to turn it over to Gino to really take us into the meat of this webinar. Gino?
Thank you, Bobby. And hello, everyone. It's great to be with you today. So, as we all know, security is a huge topic. And in order to identify the areas of focus that are important for utilities, the white paper starts with a discussion of use cases. And we were very fortunate in that the UBBA has had a use case working group in operation for quite some time. And as you can see in the graphic, a few of the popular use cases, common use cases that are in view of utility networks are shown. So they include VVO, FLISR, fire mitigation, AMI. But in addition to those, there are a number of other use cases that the working group has identified. Some of those other use cases are EV charging, smart lighting, LMR PTT interworking, drones, and many others. So the white paper includes links to a good amount of material that was developed by the use cases working group. And if you're so inclined to have a deeper view into some of those use cases, please click those links on the white paper. So click please, Bobby. So then the approach we took in the white paper is we wanted to overlay sort of a prototypical network architecture that would be implemented to support those use cases. And I'll walk through that high level architecture now because that will set the context for some of the points we make later here in the webinar. So in the main, on the far right, the utility control centers host a variety of applications, but two of the principal applications in view for security are maintenance and security operations. And one of the primary use case categories is SCADA operations. There's often SCADA operations head ends within the control center. And most typically, those functions reside behind a firewall and communicate through a corporate IT network of sorts. On the left-hand side of the diagram is illustrated utility remote stations. And the utility remote stations contain a number of different types of devices. Well, again, we've tried to identify categories of devices without trying to be too specific. So one category of devices are remote terminal units or RTUs, and the principal job of the RTU is to provide an interface between the SCADA intelligent electronic devices, sometimes called IEDs, not to be confused with improvised explosive devices. And those IEDs oftentimes interface to the RTUs with serial type interfaces, that is RS-232 or EIA 485. And protocols such as DNP3 or Modbus are typically carried over those serial interfaces. Another device within the remote stations are WAN gateway units. And the principal job of the WAN gateway unit is to provide an interface between IP native SCADA host devices with the control stations that are in the utility control centers. And the interface between those SCADA host devices and the WAN gateway unit are typically IP over Ethernet, and they also may carry the DNP3 or Modbus protocols. One other element we call out in the white paper that sometimes is overlooked is that those devices have local maintenance terminals and local maintenance interfaces that are associated with them for the purpose of install, initial configuration, and in the field, those local maintenance terminals may be required to do some debug or troubleshooting or other maintenance activities. And given that, those devices may be configured on a local area network. And as such, those local area networks provide sort of a broader interface into those devices. And in general, all of these interfaces represent attack surfaces, that is, points of entry into the network in which some sort of security control should be considered for application. In the center of the diagram is called what we've called a wide area network, but again, this is intended to be an abstracted view. The wide area network could be comprised of multiple tiers of networks that some also would call field area networks. And some of the transport technologies that are used in there are could be leased lines, point-to-point microwave links, fiber links, commercial cellular networks, and of course, private broadband LTE networks, as we'll be talking more about here. So given that these are the sort of the main, I would say, box level or device level interfaces, we are calling out that an application of security association should be considered to protect these interfaces. And attributes of this security associations are mutual endpoint authentication, authorization, data integrity, and data confidentiality. So this is kind of the top level view. I would say it's a box level view, and in some sense you might think of this as a perimeter security view. So in the next slide, we'll take a slightly different view of the network. So before we want to look at the applications, the next level view, we want to identify the applications again at a sort of a top level category view of what resides in the network. So as we mentioned previously, SCADA applications are principal in view of the applications, but in addition, some less thought of applications are those of device management, operating system management, firmware management, and SIM card management. These categories of devices should all be kept in view because they do represent additional points of interface into the network. So if you click, please, Bobby. What we want to do is identify some of these applications and where they reside within the network elements. So as you can see in the embedded devices themselves, a number of these types of applications may reside. And again, we've taken a category type view. So one such category is applications that require internet access. And we'll talk a bit more about that because that's a very controversial and interesting category of applications. But other type applications that reside within the embedded devices are SCADA gateway type devices, and then generally applications that require access into the private network or as we mentioned previously, into the system control network. And then there's device operating systems and firmware that will also need interfaces into one or more networks, and SIM cards that are used to authenticate the devices for access into the cellular or private broadband networks. So the endpoints, if you can click again, please, Bobby. So the endpoints of these applications may reside in the private networks or as described here is in the critical infrastructure network. And that's probably the best case scenario and from a security point of view. However, we still should consider having security associations between those application endpoints. And if you click again, Bobby, we can see that, Okay, there we go. We can see that others of those applications, the endpoints may reside in public application networks, and those public application networks very commonly are accessed through the internet. And here is where the internet access comes into view. And there's many reasons why these sorts of applications may reside in public networks. One such driver is, as Bobby mentioned in the opening monologue, is that COTS, or commercial off-the-shelf devices, oftentimes rely on public internet-based services to do things like enroll the devices into networks, perform operating system updates, even functions as basic as getting system time for the device itself, sometimes are gotten through services through the internet to public application servers. So while it would be nice if we could, the ideal world would be to avoid having exposure to these applications as more and more COTS type applications are deployed into the network, the greater the dependency there will be on public applications. So again, what we're showing here is that between these application endpoints, we should strive to maintain security associations, and those security associations have the same attributes as those at the box level of the perimeter level view that was shown on the previous slide. And that includes mutual endpoint authentication, integrity, protection of the data traffic, privacy, often implemented by encryption of the data traffic, and those types of things, particularly the authentication, is the machine-to-machine equivalent of identity-based security. So that is, if you were to use a banking application that's hosted on a banking server through the internet via a web browser, your web browser would authenticate the banking server by means of the server presenting a certificate to your web browser that has been signed by a certificate authority that is trusted and identified through a trust chain within your browser. And similarly, the server will authenticate the user via the username password. The idea here is that in machine-to-machine applications, that same sort of mutual authentication should be supported. However, there are costs and complexities associated with that approach. And one view might be seen here, just the sheer number of security associations that are illustrated in this diagram. But as you think about every one of those security associations requiring a unique set of credentials and overheads associated with maintaining those associations, you can see that that can get quite complex quite quickly. So in order to sort of simplify this a bit, one could take a hybrid view of the box level or the perimeter level security associations with the application level view, in that applications that reside within a common trust domain could share a security association. And that minimizes some of the complexities associated with the credential management and the processing overheads also that are involved in that. So the credential management, whether the credentials be pre-shared keys or whether they be certificates, all have life cycles that need to be monitored and tracked and maintained over time. Also, as I mentioned, the processing complexities associated with maintaining the encryption needed and having some sort of synchronization for the encryption vectors, all of those kinds of things consume resources. And so we might think of a hybrid scheme of having applications that share security associations within a trust domain as a simplification. So these are the sort of trade-offs that that could be made as a complex network is being designed and implemented, and to support that sort of a operation of that network, some very important elements of that are device monitoring and device management. So in the next slide, my colleague Jairo Hernandez Guzman will talk about security aspects of device management and device monitoring. Jairo, over to you.
Thanks a lot for that introduction there, Gino. And as you alluded to, device management plays a pivotal role within these type of applications deployed in critical infrastructure and leveraging connectivity such as private LTE. we figured that it was of importance to explore some of the aspects that fall under this umbrella within the context of critical infrastructure, and group them into these 6 categories, if you will. Each of these categories has its own set of nuances that one must explore, and perhaps paint a clearer picture as to what we mean by these categories. So like if we explore data collection methods within the context of utility networks, something that immediately comes to mind is how utilities heavily leverage DMP3 and perhaps SNMP for IP-based networks. And some consideration ought to be taken into the how these protocols are being implemented. As an example that we actually explored during in our paper is the versioning of these protocols, in that SNMP v3 implements features that we deem necessary in order to maintain secure data collection using this protocol. And similarly, DMP3 on its version 6 has features that enable security elements that are imperative these days in this type of secure application that demands this level of privacy. Now, if we switch to the context of, let's say, security monitoring, there are aspects that one can monitor for devices that reside within these networks that could convey a higher level status or state of the devices. So an example of such statistics that could be monitored through a device monitoring agent would be its location, and by its location deriving a geofencing pattern, prohibiting the device from operating where it was not designed or authorized to operate in. Similarly, impact and tilt detection could provide a valuable data point that could be leveraged to derive higher order statistics and infer other events throughout a utility network with access to this information. These are just some examples that we highlight here, but there are more security monitoring aspects and data points that can be leveraged within these networks. Similarly, there is the aspect of operational monitoring. So within the context of operational monitoring, there are several data points that convey the operational state of the device, and examples of these could be signal levels, data usage, which if we explore the example of like a higher level state that could be derived from one of these is perhaps data usage. If a pattern for the device's data and data flow is established, one could observe a deviation from said state in perhaps an instantaneous increase in data usage, and infer that there has been a breach in the network, and someone is trying to inject data, let's say a denial of service attack or the likes of which. Similarly, an instantaneous targeted signal level drop on a cluster of units could convey a jamming attack that the network could be subject to. And these are just some examples of data points that could be exposed via a device monitoring and management to a network within this context that could convey information that's valuable for utilities. On the right-hand side, we continue to explore other aspects and elements that are highly relevant to these applications. And one that comes to mind immediately is interoperability. We know for sure that it is fairly common to have a solution to perform device management on a particular vendor's device, and then you have another solution for another, and it could be quite complex to have different solutions. So it would be a benefit for the ecosystem to converge around standardized protocols that enable interoperability. Examples of these protocols that we list in our paper are lightweight machine-to-machine, which is heavily used by LTE modem vendors and within the LTE ecosystem. And similarly, we have the 2030.5 protocol, which is heavily used within the distributed energy resources. Both protocols, you could think of them as being developed from the ground up to support these applications, and they've been developed with security in mind. In the example of lightweight M2M with DTLS on its transport and socket layer security. And 2030.5 leveraging the same transport layer security mechanisms that DTLS leverages, but with TCP transport. If we then perhaps look at the solution and the device manager in the network, and want to provide a robust service that could be relied upon, one aspect that needs to be explored is its scalability. An aspect that Gino touched upon is the complexity of managing the security credentials, like let's say the lifecycle management of passwords and certificates. And one aspect that we deem imperative is that the relationship between the number of devices and the complexity of the management solution cannot be linear, in that as an example, managing 1,000 devices should not require 1,000 individual actions, or 1,000 engineers to follow up on the state of the security credentials that are needed to maintain these devices. On a similar note, to provide sustainable scalability, one could consider a cluster deployment for the device monitoring and management service, able to perform load balancing to both the front end and the back end, and ensuring that the service is not overloaded in the presence of an increasing number of devices, as we expect the trend to continue and having more devices connected to the network. On a similar note, then, branching off of the scalability, we need to touch upon the reliability and availability of the service. And one very important point is considering redundancy when crafting the deployment of said solution. Redundancy, like we discussed on the previous point on load balancing and a cluster deployment, but also redundancy can be offered in network access, having redundant network paths to this service within the context of it being accessible via the internet or being an entity present in the back office. Redundancy is of the utmost importance to ensure that the service is highly available and reliable. If we then take a step back and consider that there are protocols and practices that one can explore and enact on all of these points and these services, it could be a little difficult to perhaps handpick every single one of them to enact a particular solution. However, there are some guidelines that my colleague Adam Spratt will like to discuss with you that provide a path for approaching these. So I'll hand this over to you, Adam.
Thank you, Jairo, and thank you, Gino, too, for covering such critical areas of security for these devices. As the anchor leg of this presentation relay, I'm going to be reviewing security controls and then recent events that impact COTS and embedded device security. Historically, security in embedded devices and in IoT was really very thin, and that's why I was always told that the S in the IoT acronym stood for security. That's because there wasn't one. But as we continue to see these devices and IoT in general work its way into our utility networks and our industrial networks, we've been challenged both as vendors and as cybersecurity professionals to help bake and build security into these devices as well as around them as we implement them. So a couple of big takeaways that I would give you right off the bat is you don't have to start from scratch in creating these secure baseline for your embedded devices and IoT. While your specific use cases, some of which that we've discussed today, others that we haven't even covered yet, for these devices will ultimately guide the creation of more granular secured baselines, there are really a few good foundational standards out there that you can use to inform your securing and hardening efforts. And that's really what we do at Southern Company too. We start with our established guidelines, we point our vendors to certifying bodies, and we work together in partnership really to ensure the best possible version of the solution is implemented that meets our needs. I've also been told before that really assessing yourself against federal standards might seem to be a bit of overkill. But utilities, we are critical infrastructure. We are continuing to see attacks and action from the federal government, both of which I'll cover here in a moment. But both of these back up the necessity of securing our electric grid to a higher standard than we've done in the past. So for vendors, I would say look at what's out there, because it's your job really at the beginning to design and create these devices and solutions securely. So we recommend you start by getting your device or solution certified through an existing certification program. And there are a few out there, a couple of them that we mentioned here and in the white paper. Underwriter Laboratories has a methodology for marketing claim verification that they designate number 1376, and it is around the cybersecurity capabilities of IoT devices. There are varying levels of certification inside of this one that really depends on the cyber assurance level required for the use case that the device or the solution meets. Excuse me. And then the CTIA, or the Wireless Association, has also recently published their own cybersecurity certification for IoT devices. Again, multiple levels are available for the vendor depending on the level of cybersecurity assurance that they're interested in. I've seen this one used in a wide variety of different networks: Cat1, N1, narrowband IoT, LTE cellular, and Wi-Fi devices. For utilities, it's really in our sphere of influence to implement and secure these devices and solutions appropriately. And so again, we have a foundation of guidelines and standards that are available to help us begin. This is not an exhaustive list, but the ones that are in published form out there today, the National Institute of Standards and Technology, or NIST, has an IR that they call 8259A, that is IoT device cybersecurity capability core baseline, very much around the technical controls and hardening for IoT devices. Now, while there is an 8259A published, there's also an 8259B, C, and D that are all in draft. And all of these are designed to be in response to the IoT Cybersecurity Improvement Act of 2020. 8259B is around non-technical supporting capabilities, some more administrative capabilities that can augment and help secure the devices as well. And then C and D are around creating and then implementing risk and security profiles utilizing versions A and B, the technical and the non-technical controls. NIST also has a special publication designated 800-213 that's in draft form. That is an IoT device cybersecurity guidance for federal government. And again, you might think that that might be a little overkill, but as I've said before, utilities are critical infrastructure. We take on nation states as far as our threat actors, and so we should be holding ourselves to the highest standard possible. I would say if you really need to be reminded again why this type of COTS and embedded device security is an important and timely topic today, you really don't need to look much further than the current news cycle. Bob, if you could move that next slide, please. Thank you. So again, big takeaways here as we see with IoT attacks, and really just expanding that to cybersecurity attacks on utilities in general. If we aren't paying attention, the same things can happen to our embedded devices and our industrial IoT that happens to what we see in the consumer grade. We have notable attacks against doorbell cameras, connected fax machines, smart coffee pots, TVs, bulbs, speakers, printers, vehicles. There's even internet connected gas station pumps that were used as a jumping off point, if you will, for cybersecurity attack. President Trump really enacted certain executive orders to limit the sourcing of certain components and equipment from specific identified companies. And that started, in my mind, what was a much needed discussion around supply chain security for these components and embedded devices, as well as connected equipment as a whole. Now, while some of those acts have been rescinded, or at least put on pause by the new administration, the National Defense Authorization Act, or the NDAA, which includes Section 889, is still in place, that prohibits or blacklists, if you will, certain companies, rather, for use as components or as devices on critical infrastructure networks. There was a Department of Energy prohibition for a while that has been rescinded currently that really tried to outlaw an entire country for the same reason. The cybersecurity of the components really could not be trusted. The current administration under President Biden has actually signed his own protection of the American supply chain order that outlines 3 different sections of a 100-day, a 1-year, and then a post 1-year plan for requirements and mandates that would require reviewing and assessing, along with protecting and ensuring the logistics and the security of supply chain for certain American critical sectors, which includes energy, information technology, and telecommunications, just to name a few. And so between these types of attacks, the threat actors that we're facing, and the federal government interest in these components that we use to support our utilities, you can see the necessity to continue to secure COTS and embedded devices and these solutions more strictly than we have in the past. At that point, Bobby, I'd like to turn it back over to you to see if there's any questions and answers.
Great, thanks Adam and Gino and Jairo. You guys all did a terrific job. So let me remind everyone to use your question box, and we'll have a question and answer time here with all 3 of our speakers. We have a few coming in, but let me get us started with a question, Gino, that I was noting. Actually, one clarification on your slide number 6, someone had asked, could you quickly define what HSS is down at the bottom?
Sorry about that. Yeah, I live in this world of acronyms, and they just roll off my tongue so quickly I don't even think twice about them. So HSS is a 3G, 4G, and 5G has another acronym for it, but it's a home subscriber server, and its job is to authenticate the SIM cards. One of its jobs is to authenticate the SIM cards that are used in the devices as they access the network. So home subscriber server.
Thank you, Gino. Always like to get those definitions in when we get asked them
Sorry
so we
about
don't forget for sure. So Gino, let me stay with you then real quick. And could you spend a few minutes and talk about one of the questions that came in? What are the most important things a utility operator can do to secure their private network?
Good question. Thanks, Bobby. Yes, there are a number of things that can be done. I think we've touched on many of them in the talk here, so I may be reiterating some of the points we've made, but let me just go ahead. So first point is I think utility operators should require the deployed products to comply with security assessment certifications, as Adam was referring to, and to follow security hardening practices. I think both Adam and Jairo have mentioned that. So security certifications will provide a standardized compliance benchmark so that the security posture can be evaluated and maintained with a consistent set of requirements and criterion. And the hardening practices similarly provide consistent configurations of network elements and oftentimes follow a principle of least privilege. And the principle of least privilege is oftentimes essential to mitigating intrusion attacks. So in addition to that, establishing and maintaining ongoing periodic security assessments with vendors. I think Adam mentioned this as well, that having this ongoing vendor engagement, we all know that vulnerabilities evolve over time, and the exploitations of those vulnerabilities also evolve over time. And so identifying them on an ongoing basis and then developing plans and prioritizations to mitigate those risks in accordance with the operational use cases is another thing that's very important. And then having the ability to rapidly deploy any sort of mitigations that may come up. And this may be periodic or it may be event-driven. So we see in the news oftentimes as vulnerabilities become made known, a very rapid response is needed. So this would be an event-driven type scenario, and whereby rapidly deploying patches or configuration changes to the network, or even perhaps in worst case shutting down some parts of the network to avoid further penetration of the network is really essential. And lastly, I think Heido touched on implementing automated type surveillance systems to be able to monitor and alert of the health of the status. And similar to the scaling problem, I mean, we don't really want people looking at every single device in the network, or even at a screen, a pane of glass, to see if the devices are healthy. And so having an automated targeted alerting system is helpful. And same goes true for detecting anomalous behaviors in the network, either in the devices or the traffic patterns that those devices are abnormal in terms of what those devices are intended to do. So having those sorts of capabilities in the network are very important for operators to maintain the security posture of their network. Oh, you're muted, Bobby.
Thank you. I appreciate that, Gino, and for catching me up on that mute button. So I was going to say, Jairo, we've had a question come in for you also around this. So what would you say are the most significant security threats to a private network?
Yeah, that's a great question. Thanks for bringing it up, Bobby. One of the critical points within private networks is it's actually the access to it. So if you consider that the private network is an island, then how is it that people get to said island? In the context of, well, let's say as an example, you have a private LTE network, so then you need a SIM card to join into the network. So then perhaps you could consider the SIM card as an entry point and thus a vulnerability. So how does one gain access to the SIM card? Perhaps there are multiple avenues that could lead to such entry point. Well, maybe at the manufacturing facility. Maybe the SIM card itself is actually removable, or maybe within the process in the utilities management of the SIM card, installation into devices, or the device itself, once deployed, the SIM card could be accessible. Now, the SIM card is but one example of this entry point. Yet another one could be if the device is already deployed and you have Ethernet ports, an unused port that is enabled that someone can connect to. Let's say it's enabled with a Wi-Fi access point functionality, then you are broadcasting an SSID that regardless of whether you're doing WPA2 or WPA3, someone with enough time will try hard enough and trigger that vulnerability that exposes that entry point into your network. So these are all just examples. Perhaps one far more common and far more vulnerable within the context of utility networks could be the lack of security within serial ports and legacy equipment. If we think that perhaps a device from 5 years is secure because it's using HTTPS, we could be betting on the wrong horse, to say the least. So the continued oversight of the entry points is something that would be what I would say at the top of the list of vulnerabilities and risks within the context of private networks.
Well, that was a great answer. Jairo, thank you for that. Adam, we had a question come in because you are the utility representation here. And are there any real world examples or lessons learned from attacks on utility networks? Anything that you can share?
Absolutely. Yeah, there are real world examples everywhere, unfortunately. If you are a utility or work for a utility, you're probably well aware of the attacks that we've seen over the last few years and have been repeatedly briefed on them. And if you are a vendor and not aware of them, I highly suggest you grab one of your utility customers and ask them about it, because there's everything from small scale to very large scale things that we've seen, like the Ukraine attack, but then also even more recently between China and India. But you can read the news and Google and find examples of cyber attacks against utilities. But we also know that not all of them rather, might have been reported or even yet fully understood yet, because it takes years to contextualize attacks of that magnitude and that complexity. When something hits a utility and has an effect, it's usually an advanced persistent threat. I mentioned earlier nation states, where we're very rarely being attacked by the bored teenager in their parents' basement. but we are facing very well-funded, very well-motivated individuals. And so when it comes to lessons learned, I wish I could say that there was something great that we didn't already know, but Gino covered probably about 90% of the lessons learned, because the problem is as I said before, the foe might be better funded. We keep making simple mistakes, and we can't afford to make simple mistakes. We assume, as Jairo said, we assume a system is safe because it uses HTTPS. I tell people no system is safe unless it's powered off, disconnected, and still in a box in the wiring closet. Identity is increasingly becoming our perimeter. Jairo talked about access control. I'll also talk about identity and access management. If you're not doing that correctly, there's really nothing you can do to secure around that. You need to really understand access control and identity and access management. I would probably say monitoring. Gino brought that up earlier. If you can't tell what's happening or where it came from, you really can't learn from the mistake, even if you could spot it. Full packet captures, endpoint monitoring, network monitoring, privileged access monitoring is another one. You talk about access control into private networks. We have to watch our third parties. We have to watch the people that we allow to have access into the network for support, maintenance, break fix, upgrades. And we have to wonder about who their third parties are. Hardening and segmentation. A lot of attacks come down to, I thought that couldn't talk to that, thought that couldn't reach the internet. I would tell people, don't just take it and plug it in. Make sure that you're hardening it. Make sure that you're understanding its communication paths. Test it and test it again. Gino brought this up as well. Acceptance testing, vulnerability scanning, penetration tests. These should be routine in the life cycle of any information system that a utility is using. And then finally, one that I'm very passionate about is really make your weakest link your strongest one. And what I mean by that is train your people. If you look at the recent Florida water attack that happened around the Super Bowl, that was not stopped by a firewall. That was stopped by a person who noticed something that wasn't right and knew the appropriate action to take. And so whether it's your technical people or even your less technical people, cybersecurity education and awareness is really huge. If they don't know what to look for, if they don't know, worse off, if they don't even know who to go to when they see something that doesn't look right, then we're already failing. And so I would say make your cybersecurity education and awareness timely and make it relevant to what you do as a utility. Those are a few lessons learned, I would say, Bobby.
Certainly, and clearly a continuing effort. No one can rest for sure. We have a few more minutes, and we had some other questions come through on the Q&A box, and I'm going to open this to everybody, but maybe Gino, you can kind of take a start at it. The question is, could you talk a little bit about transitioning from a transition plan to 5G, and maybe even what some futuristic kind of infrastructure might be in the works?
Yeah, sure. Thanks, Bobby. I'd be happy to. So I think transition to 5G is important from a couple of different perspectives. One perspective is just keeping pace with technology. The world is moving around us, and it's very important to keep up with the technology components that are being deployed more widely for economies of scale and for security perspectives, for that matter, as well. The other is that 5G offers the promise of more bandwidth, higher bandwidth, which represent larger, let's say, larger attack surfaces. And also on the core side, so 5G, I kind of think as there's sort of two main areas. There's many, many more, but all of my answers I have two in there. So two main areas of improvement. One area that we don't talk so much about is in the core network side. So in the core network side, 5G offers components of attributes of network slicing, where particular network pieces can be tailored for applications, and they can be optimized for use of, say, IoT applications, so for low latency, for wide scale, a large number of devices connected to it that use a very small amount of bandwidth. So so that there's a larger number of potential endpoints that devices we'll have to talk to in a more distributed fashion with network slicing. And along with network slicing comes edge computing. So within a network slice, some of the functions that historically may have been done in a cloud context could now be done at the edge of the network. And the edge computing aspects also provide some improvements in latency, in availability, but also a lot more varied now in terms of the network architecture and the network endpoints. So the core network evolutions of 5G are very important. And I think, though, if we kind of adhere to the principles that we've been talking about today, I think those principles scale very well into the future. But I'll also talk a little bit about the RAN side of 5G and how it might impact IoT as an example. So many people may know that the new radio 5G NR, as it's sometimes called, or new radio, the air interface that provides a very high bandwidth, has a downward limit of the scalability. So it scales down to 5 megahertz channels, and 5 megahertz channels may be difficult to obtain in private broadband contexts. So NR may be a little bit beyond the current sort of horizon, but there are improvements that are being made that were started pre-5G or pre-release 15 that certainly do have implications for utility networks, and those are in the areas of IoT and machine-to-machine. So both of those technology areas are continuing to see improvements in terms of coverage expansion and throughput increases. So IoT and M2M are not forgotten in the 5G context, and that's something that we don't often see in the commercial space. We don't see a lot of discussion about 5G and those kinds of technologies, but they are being carried forward into the future, and so I think they will benefit the utility space as well. So thanks for that question.
Excellent. Yeah, that's great. We did have, I think I can get in a couple of more before we do a final wrap. We did get a question, and maybe you can just clarify. Could you talk a little bit about Jairo and Gino, perhaps you mentioned this as well, about endpoint mutual authentication on the device. You mentioned username, password certificates. Can you guys dive in just a little bit? I know it's really technical, so we can't get too deep, but do you want to dive in a little bit on that topic?
Certainly. It's the concept of mutual authentication is so that both peers that participate in the communication have to present an identity and must be validated by the other peer. It is common that within the context of using certificates as the form of authentication, one would present a certificate to the peer on the other end, and the validity of said certificate is associated against a certificate authority and the database that validates the root of trust that encompasses the validity period and the issuance, and also other parameters that describe the functionality that the device is entitled to. Similarly, when the device presents its certificate for authentication, it expects the peer also to authenticate and with a predefined method. So it could also be a certificate and validated using the same mechanism of validating the presented certificate against the certificate authority to ensure that the root of trust is maintained. The concept scales to passwords as well. So like if a username and password is presented to a server, the server must present the username and password to a device. So it's the concept of mutual authentication. That's sort of what it describes at a high level.
Okay, great. Adam or Gino, anything you wanted to add just to that, or are we good on that? Okay.
I think Jairo did a great job with that.
I do too. We have tons of questions, and I apologize to everyone who's submitting them. We'll never get to them all. So what I'd like to do is remind you all that we will be sending out the complete paper that will dive in deeper. And certainly some of you had asked about more information, deeper dives, which reaching these guys directly, I think those are great questions. And I would just say it really illustrates the power and benefits of UBBA membership, so I'll put in a plug there. If you're not already a member, please reach out to me. My email's there on the screen about joining and sitting in on this working group and really diving into these questions and sharing your knowledge as well. So we want to make sure that you know that UBBA is open to all, and certainly we'd love to get you signed in. Before we wrap up though, thank you all for the Q&A. I'd like to just go around and have you guys give just another minute or so, just closing thoughts on this. Gino, if you want to go first, I think we got 3 minutes left, so there you go.
Okay. I'll be quick. Thanks, Bobby. Well, first off, I'd like to say thanks to everyone who participated today. I really appreciate your time. I appreciate the opportunity to share my views and insights here. I'm proud to represent Motorola Solutions and our critical infrastructure business unit and the markets that we serve. I'd just like to say that perhaps we could use this as a call to action for folks who are listening here that realize that cybersecurity is essential. It's not just for the success of our business, but also it's a duty for the communities that we all serve to keep the critical infrastructures whole and intact and operating. So certainly supporting the critical infrastructure is a mission and a motivation within Motorola Solutions, and we're all very excited about that. Lastly, I'd like to thank my co-presenters, webinar participants, Jairo and Adam. Adam, you've done a wonderful job. I wouldn't have done this without you guys, so thanks so much. And thank you, Bobby. So thank you all.
Yeah.
Take care.
Thanks, Gino. Jairo?
Yeah, thanks for the opportunity. I echo your thoughts, Gino. A real pleasure to participate in this conversation with you guys. It is an opportunity that we've engaged at Council Rock with the development of secure platforms for critical infrastructure, and it is a real pleasure to being able to share the knowledge that we've obtained during the implementation of said practices and try to influence the community to converge around standardized secure practices and best practices in order to maintain a continued reliable critical infrastructure service to all of the consumers that rely upon said service. But thanks again for the opportunity to share these thoughts with the broader audience.
Thank you, Jairo. Adam, take us home.
Absolutely. It's I would say with such great co-authors and co-presenters like Gino and Jairo, it's hard to come up with something new to say other than just to echo what they've said before. But I'll take this moment not only to thank them and to thank Bobby and the UBBA for this opportunity, but also really just to drive home some of the points that we've mentioned throughout this, that we have to do it together. You know, even within a utility, I cannot secure a utility unless the business unit will work with me. But as we move into the future, as we move into things that Gino brought up, 5G being bigger, faster, stronger, grid edge, distributed resources, we're going to have to do this together. Industry groups like the UBBA, which they do an amazing job, bringing vendors and utilities together, not just to fix solutions, but also impact regulatory where we can, governmental where we can. We really are going to have to work together to secure this as we continue to move into the future. So might seem like a shameless plug for the UBBA, but be active, be present, and be willing. We're going to have to work together.
I could not have said it better, gentlemen. Thank you all so much. Thank you to everyone who attended. I hope you have a wonderful day, and we'll be following up. Take care.
Cheers. Thank you.
Thank you.